This is the Edexcel higher tier, paper 1, non-calculator paper from November 2019. Question 1 says find the lowest common multiple of 108 and 120. So we can break these numbers down into their prime factors to answer this question. So if we start with 108, we can pick any two numbers that multiply to make 108. Let's do 2 times 54. 2 is prime. 54 is 2 27s. Again, 2 is prime. 27 is 3 9s. 3 is prime. And 9 is 3 times 3. So that's 108. Broken down to its prime factors, 108 is 2 times 2 times 3 times 3 times 3. For 120, we can break it down to 2 times 60. 2 is prime. 60 is 2 30s. 2 is prime. 30 is 2 times 15. And again, 2 is prime. And 15 is 3 times 5. Both of which are prime. So now I've broken them both down into prime factors. We can draw a Venn diagram. So if we have a Venn diagram, one circle for the factors of 108, the prime factors of 108, one for the prime factors of 120. So they share a 2, another 2, and a 3. They go in both circles. Then the 108 circle is going to have another 2 3s. And the 120 circle has got a 2 and a 5. The lowest common multiple, the lowest number in the 108 and 120 times tables, is going to be all of these numbers multiplied together. So 3 times 3 times 2 times 2 times 3 times 2 times 5. But remember, the 108 circle multiplies to make 108. So it's 108 times 2 times 5, or 108 times 10, which is 1080. Question 2. There are 60 people in a choir. Half of the people in the choir are women. So half of 60 is 30. The number of women in the choir is 3 times the number of men. So a third of 30 is 10. The number of women, 30, is 3 times the number of men, which must be 10. The rest of the people are children. So there are 60 people in total. We've got 30 and 10, which is 40, which means 20 more. The number of children in the choir to the number of men in the choir is n to 1. So we're writing the ratio of children to men. So there are 20 children and 10 men. And we need to write that in the form n to 1. So if we divide both by 10, we've got 2 to 1. So n is 2. Question 3. Work out 1 3/4 times 1 1/3. Give your answer as a mixed number. We can't multiply fractions when they're written as mixed numbers, so we need to convert them to improper fractions before we can multiply them together. So we've got 1 whole 1 3/4. A whole 1 is 4/4. So 1 times 4 is 4. Add the 3. So 4/4 3/4 make 7 quarters. 1 3/4 is the same as 7 quarters. 1 1/3, 1/3 is 3. So we've got 3/3 and 1/3. That's 4/3. 1 1/3 is the same as 4/3. So now we just need to times these fractions together. If we want to, we can simplify them first, which will make it easier. So we can divide the top and the bottom by 4. Now we'll just times the top times the bottom. 1 7 is 7, 1 3 is 3. So 7/3. It's not a mixed number, so we need to change it for our final answer. How many whole ones do we have? How many 3s go into 7? It goes in 2 times, so there are 2 wholes. That would be 6/3, and there's 1 more third. So we've got 2 and 1/3. Question 4. Use a ruler and compasses to construct the line from the point P perpendicular to the line CD. You must show all construction lines. So we need to take our compass and place the point of the compass on P, on the point P. And we're going to draw an arc that's going to give us 2 points that are on this line CD. So there'll be 2 points, needs to be a little bit longer. So there'll be 2 points that are an equal distance from P. We've got 2 points an equal distance from P. And then from each of these 2 points, I'm going to draw another arc. So from each of the 2 points, I'm going to draw another arc. And where those 2 arcs meet will be another point equal distance from these points. So if I connect P to my point down here, I will have a perpendicular line. So if I connect P to my point down here, I've got a perpendicular line. So that is my perpendicular line. Question 5. The diagram shows triangle ABC. And in our triangle, we've got another line CD. It says ADB is a straight line. The size of angle DCB to the size of angle ACD is 2 to 1. So this angle here is twice this angle here. We can call the small angle X, and the bigger angle that's twice its size, that's 2x. Work out the size of angle BDC. BDC, we're working out, this is our unknown angle up here. So we can find out what x is first by using the triangle ABC, the whole triangle. Angles in a triangle add up to 180 degrees. So we've got 75, 51, and 3x. So 75 plus 51 plus 3x equals 180. The angles in the triangle add up to 180 degrees. 75 and 51, if we add them together, we get 126. So 126 plus 3x equals 180. We want to get x by itself, so let's take 126 away from both sides. 3x is equal to 54, and then divide both sides by 3. 54 over 3 is 18. So x is 18 degrees. That's our smaller angle here. This is 18 degrees. 2x is double 18, which is 36 degrees. So now we can use the triangle BCD, and again use angles in a triangle add up to 180 degrees. So this time we've got 51, 36, and our missing angle that we're trying to work out. 51, 36, 51 plus 36 plus our y is equal to 180 degrees. 51 and 36 make 87. So 87 plus y is 180. Taking 87 away from both sides. So take away 80 for 100. Take away another 7. 93 degrees. So that's the size of angle BDC. Question 6. 4 red bricks have a mean weight of 5 kilograms. 5 blue bricks have a mean weight of 9 kilograms. 1 green brick has a weight of 6 kilograms. Donna says the mean weight of the 10 bricks is less than 7 kilograms. Is Donna correct? So we need to find the mean, we need to add them all up, the total weight divided by how many. So the 4 red bricks have an average of 5, have a mean of 5. 4 5s is 20 kilograms. So they add up, these 4 bricks in total weigh 20 kilograms. 5 bricks have a mean of 9. 5 9s are 45. So those 5 bricks weigh 45 kilograms, and the other brick weighs 6 kilograms. So the total weight is 20 plus 45 plus 6. 65 and 6 is 71 kilograms. That's the total weight. The mean is going to be 71 divided by how many, which is 10. 71 over 10 is 7.1. So the mean weight is 7.1 kilograms. So is Donna correct? Donna said it's less than 7, and it's not, it's more than 7. So no, Donna is not correct. 7.1 is bigger than 7. Question 7. Simplify p squared to the power of 5. When we've got indices in a bracket, we times the powers. 2 5s are 10. It's p to the power of 10. That's because the power of 5 means times itself 5 times. So it's p squared times p squared times p squared times p squared times p squared. And each p squared is a p times p. So we've actually got 10 p's multiplied together here. Part B, simplify 12x to the power of 7 y cubed divided by 6x cubed y. So we're going to divide the numbers, divide the x's, and divide the y's. 12 over 6 is 2. X to the power of 7 divided by x cubed is x to the power of 4. When I'm dividing indices, I'm taking away the powers. And y cubed divided by y, 3 take away 1 is 2. Question 8. The accurate scale drawing shows the positions of port P and a lighthouse L. 1 centimeter represents 4 kilometers. Alina sails her boat from port P on a bearing of 70 degrees. So from port P, that means from the north line, 70 degrees. She sails for 1.5 hours at an average speed of 12 kilometers per hour to port Q. So we need to draw on port Q, and then we're going to find the distance of Q to L. So Q's over here somewhere. We have to measure the distance Q to L and the bearing of Q from L. So the angle from L to Q. So we know we're going 70 degrees. We don't know how far. So speed is equal to distance over time. Distance, if we multiply both sides by time, is speed times time. So it's 12 times 1.5. So 12 times 1.5. 1.5 12s will be 18. So 18 kilometers. 1 centimeter for every 4 kilometers. 18 over 4 is the same as 9 over 2, or 4.5 centimeters. So we want to go 4.5 centimeters on a bearing of 70 degrees. So let's get the protractor, line up 0 with the north line. Line up 0 with the north line, and then measure around 70 degrees. So from 0 up to 70. So that's here. And then in that direction, we want 4.5 centimeters. So 4.5 centimeters in this direction will take us to there. So that's the point Q. That's the point Q. The question said we want the distance from Q to L. So we're measuring this distance now from Q to L. And we've got 5.5 or 5.6. 5.5 centimeters. So 5.5 centimeters. Each centimeter is 4 kilometers. So 5.5 times 4, double 5.5 is 11, and double it again, that's 22. So 22 kilometers. That's the distance. The bearing, so let's draw this line on. It's the bearing of Q from L. So it's from L, and it's from the north line of L clockwise. So we always measure a bearing clockwise from the north line. So it's this angle around here that we want to work out. The bearing of Q from L. So we're starting at L, we're measuring from the north line clockwise. How can we measure the angle? So our protractor only goes up to 180 degrees. So what we can do is measure the small angle and do 360 takeaway answer. So if we measure the angle in here, which is 38 degrees. So 38 degrees in there. So our bearing is going to be 360 take away 38. which is 322 degrees. Question 9. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? So again, speed is equal to distance over time. We want distance, so we're going to do speed times time is equal to the distance. The units we've got here, we've got 18 minutes and 72 kilometers per hour. So we can't just multiply these two together. We have to change the minutes into hours. And the easiest way to do that is just to write it as a fraction. So distance is speed times time. So 72 times 18 over 60. 72 times 18 over 60. And we can simplify that fraction. So 18 over 60 is the same as 9 over 30. And dividing by 3 again, 3 over 10. So 72 times 3 tenths So 72 times 3. 72 times 3 is, so 7 times 3 is 21. So 70 times 3 is 210, plus 2 3s, which is 6. So that's 216 over 10, which is 21.6 kilometers. David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? You must show how you get your answer. So 72 kilometers per hour is the same as, well, a kilometer is 1,000 meters. So that's the same as 72,000 meters per hour. And in an hour there are 60 minutes, and in a minute there are 60 seconds. So there are actually 60 times 60 seconds in an hour. 6 6s are 36. Add on the 2 zeros. 3,600 seconds in an hour. So if we're going 72,000 meters in an hour, to find out how far we go each second, we need to divide by 3,600. Divided by 3,600, and that will be meters in a second. Divide top and bottom by 10, and by 10 again. How many 36s go into 72? That's actually 2. So this is actually 20 meters per second. Dividing top and bottom by 36 gives us 20 meters per second. So is David correct? Well, it's not faster, it's the same. So no, 72 kilometers per hour is equal to 20 meters per second. Question 10. The cumulative frequency table shows information about the times in minutes taken by 40 people to complete a puzzle, and we need to draw a cumulative frequency graph. So on a cumulative frequency graph, we're plotting this top point against the cumulative frequency. 40 against 5. So 40 against 5, that's here. 60 against 25. 80, 35. 138, and 120, 40. So we're going to join these up. We could use a smooth curve, or we could use straight lines. I'm going to use straight lines because I'm going to find it easier. Part B, use your graph to find an estimate for the interquartile range. So we have 40 people. 40 people. So a quarter of them, the lower quartile, will be from 10. So we'll go from 10 to our graph and down. $45, I think. And we'll go for 3/4 of 40, which is 30. Again to our graph and down, and that seems to be at 70. So if this is 45, halfway between 40 and 50, this one is 70. So our interquartile range, 70 take away 45, which is 25 minutes. There'll be a range of acceptable answers depending on your graph. One of the 40 people is chosen at random. Use your graph to find an estimate for the probability that this person took between 50 and 90 minutes to complete the puzzle. So between 50 and 90 minutes. So let's have a look. Between 50 and 90 minutes. 50 minutes is here, which seems to be 15, and 90 minutes up here so we have 15 and 37. Looks slightly closer to 37. So how many people in between 15 and 37? 37 take away 15 is 22 people, and it's out of 40. So 22, it's a probability. We can write it as a fraction, a decimal, or a percentage. 22 out of 40. We don't need to simplify it, so I'm not going to. Question 11. There are P counters in a bag. 12 are yellow. Shafiq takes at random 30 counters from the bag. 5 of these are yellow. Work out an estimate for the value of P. So we've got a capture-recapture question. 12 out of P are yellow, and 5 out of 30 are yellow. So these are equivalent fractions. 12 over P is equal to 5 over 30. So what does P have to be? We can simplify 5 over 30. So divide top and bottom by 5. So 12 over P is the same as 1/6. So what does P have to be? Well, 6 times 12, which is 72. 12 over 72 is the same as 1/6. Question 12. T equals Q over 2 plus 5. Here is Spencer's method to make Q the subject of the formula. So his first step, he's multiplied by 2 but he hasn't multiplied every term by 2. So if he's multiplying by 2, he would have to multiply every term by 2. So that will be 2t equals q plus 10. If you multiply by a number, you need to multiply every term in the equation by that number. So he didn't multiply the 5 by 2. Question 13. Write 5 over x plus 1 plus 2 over 3x as a single fraction in its simplest form. To add fractions, we need to make the denominators the same. So for my 5 over x plus 1, I'm going to multiply top and bottom by 3x. And for my 2 over 3x, I'll multiply top and bottom by x plus 1. So now I've got a common denominator. I can add the fractions. So I can write them as a single fraction with a common denominator. So I've got 5 times 3x plus 2 times x plus 1. If I now expand the top line, so 5 times 3x is 15x, 2 times x is 2x, and 2 times 1 is 2. Now, simplifying the top line, 5x and 2x makes 17x, so I've got 17x plus 2 on the top, and on the bottom I can leave this as it is, as factorized. If you wanted to expand it, that would be absolutely fine. It would be 3x squared plus 3x. Part B, factorize x plus y squared plus 3 times x plus y. So the common term here is x plus y. They both have an x plus y in them. It looks complicated, but it's the same as if it was just a squared plus 3a. You would factorize out the a. You'd say a times a plus 3. We're doing exactly the same thing, but with an x plus y. So we're going to take x plus y on the outside. X plus y times another x plus y is x plus y squared, and x plus y times 3 is 3 times x plus y. So that's our final answer. It's x plus y times x plus y plus 3. Question 14. The diagram shows a right-angled triangle. All the measurements are in centimeters. The area is 27.5 centimeters squared. Work out the length of the shortest side. You must show your working. So to find the area of a triangle, or a right-angled triangle at least, we can use base times height divided by 2, or half times base times height. So half times base times height equals the area, which is 27.5. We now need to solve this equation. So we can get rid of the half by doubling both sides. So we'll have x plus 4 times x minus 2 equals double 27.5, which is 55. Now we can expand these brackets we're going to want, well, let's expand the brackets first. So x times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. And that equals 55. Now, collecting our terms, we've got negative 2 plus 4, which is 2 for the x's. So x squared plus 2x. And we've got minus 8. And because it's a quadratic, we want to make it equal to 0 before we solve it. So we're going to take 55 away from both sides. So negative 8, take away another 55, will be negative 63. So we're solving a quadratic now. The easiest way to do that will be by factorizing. So we're going to factorize this. So it's x squared, which means we're going to have x times x. What multiplies to make 63, or a negative 63, and adds to give us a positive 2. 63 is 9 times 7. So to get a positive 2, we can have plus 9, take away 7. So what's x equal to? So for this to be equal to 0, either the first bracket's got to be 0, so x would have to be negative 9, or the second bracket 0, so x would have to be 7. And x can't be negative 9, otherwise these lengths would be negative, so x must be 7, and the shortest length is 7 take away 2, which is 5 centimeters. Question 15. Express 0.418 recurring, so 0.4181818181818 and so on, as a fraction. You must show all your working. So to do this, we need something that ends in the 18 recurring. So if we call 0.418 recurring x, and we multiply by 10, we'll have 4.18 recurring as 10x. We now want something else ending in the 18 recurring, and if we multiply the original by 1000 or the 10x by 100, either way, we'll get 418.18 recurring, and that's 1000x. So now we've got two things ending in the 18 recurring. We can take them away, and that will get rid of all those recurring numbers. So 1000 x's take away 10 x's is 990 x's. 418 point something take away 4 point something is 414. So now we can get x by itself by dividing both sides by 990. So it's going to be 414 over 990. It doesn't say we have to give our answer in its simplest form, so we will be okay leaving it as it is. Question 16. Rationalize the denominator of 22 over root 11. Give your answer in its simplest form. So when we're asked to rationalize a denominator, that means we want to get rid of the square root. We don't want a square root on the bottom. So if we multiply the bottom by square root 11, we can get rid of square root 11. But if we multiply the bottom by something, to keep the fraction the same, we have to multiply the top by the same thing. So multiply top and bottom by root 11 gives us, on the top, 22 times root 11 is 22 root 11. And on the bottom, root 11 times root 11 is 11. Now to simplify this, we can divide top and bottom by 11. 22 over 11 is 2. So we're left with 2 root 11. Part B, show that root 3 over 2 root 3 take away 1 can be written in the form a plus root 3 over b, where a and b are integers. So to rationalize the denominator this time, we're going to use the difference of two squares. So we're going to times top and bottom by 2 root 3 plus 1. And that will get rid of the surd from the bottom. That's because when you've got two brackets, one with a plus, one with a minus, but they've got the same terms otherwise, the middle bit cancels out. And I'll show you that as I expand it. So for the top, I'm going to expand this bracket. Root 3 times 2 root 3. Root 3 times root 3 is 3. 2 3s are 6. Root 3 times 1 is just root 3. On the bottom, 2 root 3 times 2 root 3. 2 2s are 4. Root 3 times root 3 is 3. So we've got 4 times 3, which will be 12. 2 root 3 times 1 is 2 root 3. Negative 1 times 2 root 3 is minus 2 root 3. And minus 1 times plus 1, positive times a negative, is negative 1. So now on the bottom, we've got 2 root 3, take away 2 root 3, which is nothing. So we've just got 6 plus root 3 on top, and we've got 12 take away 1, which is 11 on the bottom. And that's the form we wanted. So A is 6, B is 11. Question 17. A and B are two similar cylindrical containers. So they're similar, that means one's an enlargement of the other. The surface area of container A to the surface area of container B is 4 to 9. The ratio for surface areas is 4 to 9. So for surface area, A to B is 4 to 9. The scale factor for area is scale factor squared. So the scale factor for length will be the square root of this. Square root 4 is 2. Square root 9 is 3. And the scale factor for volume is scale factor cubed. So 2 cubed is 8. 3 cubed, 3 times 3 times 3 is 27. So this is what we're going to be using. Let's see what the question is. Tyler fills container A with water. So this is volume. It's going to be a volume question. She then pours the water into container B. Tyler repeats this and stops when B is full of water. How many times will Tyler fill container A with water? You must show you're working. So the volume of A is 8 parts. The volume of B is 27 parts. So we're going to fill it once. That'll be 8. I then fill it twice, which will be 16. So it's still not 4. 3 times, 24. There's still room for some more. And so it's going to be 4 times. It's going to be filled up. We're going to fill up A 4 times before we've filled B up. So 4 times. Question 18. The function f is given by f of x equals 2x cubed minus 4. Part A says show that f minus 1 of 50 equals 3. So if you put 50 into the inverse function, you get 3 out. In an inverse function is the opposite function. So the output becomes the input, and the input becomes the output. So for this function f of x, if the output is 50, the input is 3. So we're showing that if the input is 3, the output is 50. So if we do f of 3, we should get 50 because the input and the output switch around. So 2 times 3 cubed minus 4. 3 cubed is 3 times 3 times 3, which is 27. So 2 27s take away 4. 54 take away 4. It is 50. So the input is 3, the output is 50. So for the inverse function, if you put 50 in to the inverse function, you get 3 out because the input and the output switch around. The functions g and h are given by g of x is x plus 2 and h of x is x squared. Find the values of x for which hg of x equals 3x squared plus x minus 1. So hg of x means we put g into h. So hg of x means putting g into h. So g is x plus 2. If we put that in to h, so h of x plus 2 is x plus 2 squared. So we're now making that equal to 3x squared plus x minus 1. So x plus 2 squared equals 3x squared plus x minus 1. And we're going to solve this equation. So x plus 2 squared, we can rewrite as double brackets, x plus 2 times x plus 2. And then we can expand those brackets. So x plus 2 squared equals 3x squared plus x minus 1. Expanding the double brackets, x times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 2's are 4. And that's still equal to 3x squared plus x minus 1. I'm going to collect the like terms first. So 2x plus 2x is 4x. And now we're going to have a quadratic, which we're going to solve by making it equal to 0. I'm going to bring all the terms over to the right side, because then my x squared term will be positive. So 3x squared take away x squared is 2x squared. X take away 4x is negative 3x. And negative 1 take away 4 is negative 5. So now we want to solve this. We're going to solve it by factorizing. And I've got a number in front of the x squared. So I'll do a times c, 2 negative 5s or 2 5s are 10. What multiplies to make a negative 10 and adds to make a negative 3? It's going to be 5 and 2. And it will be a plus 5 and a negative 2. So I'm going to rewrite my quadratic as 2x squared plus 2x minus 5x minus 5. So I've uncollected the like terms here. Now I'm going to put it into double brackets. So what can I take out of the first two? 2x squared and 2x. They've both got a 2x in them. So that becomes my first term. And then if I expanded, 2x times something is 2x squared. 2x times x is 2x squared. 2x times 1 is 2x. And then minus 5 times x is minus 5x. And minus 5 times 1 is minus 5. So what's x? What makes the first bracket 0? X would have to be 2.5 or 5 over 2. Or what makes the second bracket 0? X would have to be negative 1. Question 19. Given that 9 to the power of negative a half equals 27 to the power of a quarter divided by 3 to the power of x plus 1, find the exact value of x. So we've got 9, 27 and 3, and they are all powers of 3. So I'm going to change each of these terms into a power of 3. So I'm going to rewrite 9 as 3 squared and rewrite 27 as 3 cubed. So that will give me 3 squared to the power of minus a half is equal to 3 cubed to the power of a quarter divided by 3 to the power of x plus 1. When we have brackets with our indices, we times them. So 2 times minus a half is negative 1. So 3 to the power of negative 1. 3 times a quarter is, well, 3 quarters. So 3 to the power of negative 1 equals 3 to the power of 3 quarters divided by 3 to the power of x plus 1. And if I rewrite that divide as a fraction, it will make the next step clearer. So I want to get rid of that divide, and I'm going to do that by multiplying both sides by 3 to the power of x plus 1. So I can get rid of that by having 3 to the power of minus 1 times 3 to the power of x plus 1 equals 3 to the power of 3 quarters. When we multiply indices, we add the powers. So here we're going to add the powers. So we've got minus 1 plus x plus 1, and that is just 3 to the power of x. Minus 1 plus 1 is nothing. 3 to the power of x equals 3 to the power of 3 quarters. So x must be equal to 3 quarters. So x is 3 quarters. Question 20. The graph of y equals f of x is shown on the grid. Draw the graph with equation f of x plus 1 inside the bracket, then minus 3 outside the bracket. So inside the bracket changes the x, and it does the opposite to what it says. So inside the bracket changes the x, and it says plus 1. So we're going to go minus 1. We're going to go to the left one. Minus 1 in the x direction. And outside the bracket changes the y, and it does what it says. So it's going to go down 3 in the y direction. So we're moving this graph left 1, down 3. So each point is going to go left 1, down 3. Left 1, down 3. Left 1, down 3. And over here, left 1, down 3. And left 1, down 3. And we'll just join them up. So we've moved each of the points left 1 and down 3. the point A, negative 2, 1, lies on our original graph. So the point A. When the graph of f of x is transformed to the graph with equation y equals f of minus x, point A is mapped to point B. Write the coordinates of point B. So originally we were here. We've got a minus inside the bracket. So all of the x coordinates, all the positives become negatives. All the negatives become positives inside the bracket. So we're only changing the x. So it becomes 2, 1. Question 21. Sketch the graph of y equals 2x squared minus 8x minus 5, showing the coordinates of the turning point and the exact coordinates of any intercepts with the coordinate axes. So we are going to complete the square. If we complete the square, we will find the turning point, and we will also be able to find, by solving it after we complete the square, where it crosses the x-axis. So if we complete the square first, so we've got y equals 2x squared minus 8x minus 5. I'm going to factorize out the 2 first, from the first two terms at least. So I'm going to factorize out the 2. So 2 times x squared and 2 times minus 4x. Now I'm going to complete the square on the bit inside the bracket. So I'm going to have x minus 2 squared. I'm halving this number, halving the x term. So it was negative 4. It's now negative 2. And I'm writing that as a square. But now I'm going to take away whatever this number squared is. So 2 squared is 4. Take away 4. So x minus 2 squared, take away 4, is the same as x squared minus 4x. If we expanded it, we would end up with the same thing. Now I'm going to expand this bracket back with a 2 again. So 2 times x minus 2 squared is 2 times x minus 2 squared. 2 times negative 4 is negative 8. And we've got a minus 5 as well. So it's 2 times x minus 2 squared minus 13. So that gives us a turning point at what makes the bracket 0. That's the smallest thing we can get. That's when x is 2. And when x is 2, all of this is worth 0. So we've got minus 13 left. So the turning point is at 2 minus 13. But we also need to know where it crosses the axes. So this is y equals. So it crosses, let's do crosses y when x equals 0. That's easier. So when x is 0, we have y equals 2 times 0 squared minus 8 times 0 minus 5. So 2 times 0 is 0, 8 times 0 is 0. So y is negative 5. So it crosses y at negative 5. And the graph will cross the x-axis when y equals 0. And if we use our completed the square version, we've got 0 equals 2 times x minus 2 squared minus 13. Then we can plus 13 to both sides. 13 equals 2 times x minus 2 squared. Divide both sides by 2. 13 over 2 equals x minus 2 squared. Square root both sides. But remember, we do the plus or minus, the positive and negative square root. And finally, to get x by itself, plus 2 to both sides. So 2 plus or minus the square root of root 13 over 2. So they are the 2 points where it crosses the x-axis at 2 plus root 13 over 2 and 2 minus root 13 over 2. So now we can do our sketch. So we've got x and y. So we've got our turning point at 2 minus 13. So 2 minus 13. And it crosses the y-axis at -5. And I'll get the right shape. So we've got a quadratic graph that looks something like that. And we're crossing the x-axis at 2 minus square root 13 over 2 and 2 plus square root 13 over 2. So there is our sketch. Question 22. A, B, C, and D are 4 points on a circle. AEC and DEB are straight lines. Triangle AED is an equilateral triangle. AED. So that means that all the lengths in AED are equal and all the angles are equal, all 60 degrees. Prove that triangle ABC, A to B to C, is congruent to triangle DCB. Is congruent to triangle D to C to B. So we're proving that these two triangles are congruent. So what do we know? So angles in the same segment are equal. So these two angles up here must be equal. Angles in the same segment are equal. We could also say angles in the same segment for quite a few different angles. So this one and this one are in the same segment. Then again, also we could say that this 60-degree angle comes from the points A and B, as does this one here. So that makes this one 60 as well. These two angles are angles in the same segment. And looking the other way, so from the points from this chord, from CD, we've got this 60-degree angle coming out from it, and also this angle at B here. So this one is also 60. And because of opposite angles, this one's 60 as well. So this triangle, BCE, is also equilateral. So all three of those lengths are equal. So do we have enough to prove that these are congruent? So we've got a 60 and a blue, a 60 and a one in the middle that's common. So we could have that one. Or we've got a purple, then a common, and then a 60 in both of them. Purple, common, 60. So we've got options for our rules. Let's write one of them down. So let's go with angle side angle. So BC is common to both. So we'll have that as our side. BC is common to both triangles. And then we've got these two blue angles being equal. So that's ABD is equal to ACD, because angles in the same segment are equal. We have these two equal, so actually we need to know it's 60 degrees, don't we? So all angles in ADE are 60 degrees. Because it's an equilateral. And then we can say that ACB and CBD are both 60 degrees as well, because angles in the same segment are equal. So we've got our common one, and we've got, no, we haven't named CBD, we've done that one. So we've both got, for both of them, we've got angle, side, angle. So therefore, angle, side, angle, and ABC is congruent to DCB.